Okay, here in Calculus AB, we're moving on to section 2.3, evaluating limits analytically. And using the word analytically might make it seem like it's harder, but in actuality, you know, if you have a really easy example, find these limits. The limit as x approaches 2 of, say, x squared minus 6x plus 1. Well, to be quite honest, if you just have any kind of function, especially a polynomial, honestly, the limit will always be f of whatever that is. If f of x is x squared minus 6x plus 1, f of 2 would be 4 minus 12 is negative 8, plus 1 would be negative 7. So, rule number 1, finding or evaluating limits analytically is plug in if possible. Even if I ask you to find the limit as x approaches 2 from the left or the right of x squared minus 6x plus 1. It is still negative 7. The left and the right limits would actually agree there, and it would be just an easy plug and chug. So, rule number 1, I'm telling you, even if it were a trig function, again, sine of x is a nice smooth curve. If we are taking left and right limits as x approaches pi over 2, well, the sine of pi over 2 is actually 1, so the right and the left are going to that 1, easy peasy. When it gets a little bit tricky is if we have 0 over 0. Then, for now, we have to do some algebra. In other words, we have to reduce if possible. Okay? So, limit as x approaches 2 of x squared minus 4 over x minus 2. So, always go through step 1, plug and chug. 2 squared is 4, 4 minus 4 is 0, 2 minus 2 is 0. Uh-oh, I don't have a clue what that is. And in fact, if I were looking for just f of 2, I would have to say f of 2 is undefined, right? But it doesn't matter what happens exactly at 2. What matters is to the left and the right of 2. And so do some algebra means let's rewrite it and let's factor if at all possible. Well, yeah, it's the difference of 2 squares. And look, we cancel out what I call the offending factor right there. So the limit of these two things is actually the same. So the limit of this function right there is exactly the same as the limit of this function. And therefore, plug and chug. 2 plus 2, 4. Done. Let's show it graphically, or not. Well, I guess you could show it graphically, but let's show it using our calculator. X squared minus 4, x minus 2. Go to our table. Oops, I thought I'd already table set it. And we want to put numbers to the right and the left of 2. 1.99999, 2.00001. Looky there, both sides closer and closer to 4. So that was if we got 0 over 0. Now, if we get a number over 0, then the limit does not exist. The limit does not exist. For those Mean Girl fans. In this case, 3 squared is 9, plus 4 times 3 is 12. 9 plus 12 is 21 over 0. So this limit, we just have to say, does not exist, because we get a number divided by a 0, and 0 can't multiply by anything to get that number. So that is the bottom line for evaluating limits analytically. Now, we may get a little bit trickier. Let's go to the little higher order problems. Actually, this looks very, very similar to number 4, doesn't it? If I plug in a 0, I get 0 over 0. Bottom line is 0 over 0 tells me, hey, I need to keep going, okay? We will have some really cool tricks for these 0 over 0 ones after we finish chapter 3. But for right now, let's just factor that denominator. Factor an x out, and we see the x will cancel or reduce. Now we're to the point we can replace the x with a 0. 3 times 1 is 3. There it is. If you need to go to your calculator to prove it to yourself, prove it to yourself. Now, that algebra extends a little bit. What if I have this weird thing? Plug in the 0. 3 plus 0 is 3. The square root of 3 minus square root of 3 is 0 over 0. But what in the heck could be factored out? I have no idea. So I said do some algebra. Well, there's some other tricks in algebra, and I have called them fancy forms of 1 over and over and over again. In this case, that weird, the square root stuff is in the numerator. Well, I'm going to rationalize the numerator. That's a legal maneuver as long as it is a fancy form of 1. So, guys, if you notice the way I'm writing my limits every time, I believe that's good mathematical language. Don't just write equals, because that limit does not actually just equal the function. It is only equal to the number once you've plugged in that little value there. So distribute, I get 3 plus x. Because we used a conjugate, the outer and the inner will always cancel. And minus regular 3. In the denominator, please don't, oops, that's supposed to be an x. Please don't distribute, or that'll ruin it for you. So leave it all factored out down there. And you'll see 3 minus 3 is gone. And I have a plain x over a plain x, which can reduce out to be 1, right? 1 on top, 1 on the bottom with that weird stuff. And at that point, we can now go, oh, okay, that now equals whatever it is when we replace x with 0. The square root of 3 plus square root of 3 is 2 square root of 3. And I'm perfectly fine with that unrationalized answer. Occasionally, If you look up answers in the back of this book, they stinking rationalize them. No rhyme or reason for that one. It's another type of problem you might see. The limit as x approaches 0 of 1 over x plus 4 minus 1 over 4 over x. That's a weird one, but 1/4 minus 1/4 is 0 over the 0 once we plug in. Again, it's our little cue that says we need to keep working, do some algebra, and in my world, it requires another fancy form of 1. The one that cancels out both of those denominators would just be a 4 times an x plus 4. So now when we distribute, the x plus 4s are gone. 4 times 1 is 4. Here, we have a minus. The 4 is gone, and we're left with an x plus 4. Again, do not distribute, or you're going to have to do more work in the end to factor out. But when I distribute this negative sign, now you'll see that the 4s are gone, and I have this plain negative x and a plain x down there. Limit as x approaches 0, so cancel those. I'm seeing a negative 1 on top. The 4 is left in the x plus 4, and now we get to the point. I'm not writing my limit anymore. By the way, one mistake I see, kids are like, well, Miss Washington said I had to write limit. So they even write limit in their answer. Well, I stop it here because once I replace my x with the 0, I'm looking at my answer. 0 plus 4 is 4 times 4 would be 16. One last kind of ugly algebraic type problem you could see is this one. What number am I on? 9. The limit as h approaches 0 of x plus h quantity squared minus 2 times x plus h minus x squared minus 2x all over h. And what happens? If I replace all those h's with the 0, I end up with an x squared minus a 2x minus an x squared plus a 2x. I end up with my 0 over 0 again. Guys, this is a preview of what's coming up at the start of chapter 3, but this is just good practice. The algebra we might need to perform here is just some FOILing out. X squared plus 2xh plus h squared. Remember FOILing that out. Distributing again, plus 2x. And what you'll see is a bunch of junk canceling. Everything else that's left, those last 3 terms, all have an h in them. So I'm going to factor that h out. Guys, don't hesitate to stop the recording, to take a break so you can copy down. I know I write things kind of fast. Those h's will cancel, but that way you'll be able to keep up and I can still kind of move through. The h approaches 0, so I replace that h with a 0, and I'm left with 2x minus 2. That's a little interesting answer, but that is how it works. Pretty sure that's about it for the limits analytically. We have this random little, random little theorem called the squeeze theorem. And the squeeze theorem simply says, if the limit as x approaches some a of f of x equals the limit, I don't know why I did cursive imprinting, x approaches a of g of x, let's just say equals L, and h of x is squeezed between f of x and g of x. In other words, all the f values are less than or equal to the h values, and the h values are less than or equal to the g values. Then the limit as x approaches a of h of x must be exactly the same as the other two. I personally think this is such a rare thing that could even occur. You know, I just don't understand. But if at some point in time you're given sometimes it's not even defined. You might just be given this, that h is always in between f and g. And so if at some x value, a, both of the limits are the same, then the limit of that middle one would have to be the L. I'm not even sure that I'm gonna put, there might be one problem from homework. So your assignment is on your content folder, so good luck.